Well, what about cars? I don't need to point out that, the price of petroleum is volatile. It comes from places that don't really like us. You can define for yourself, okay, well, local pollution, that's a bad thing. Some people accept global warming, some people still don't. But, yeah, so what comes after petroleum? Hydrogen, maybe? Well, this was in the Bush 2003 State of the Union address. Quick paragraph. One paragraph out of the speech. Let's see. It's going to be a zero pollution fuel. Yeah, like I said, hydrogen, oxygen, water. Just water out of the tailpipe. Abundant. Hydrogen is claimed to be the most abundant element in the universe. And with just $1.2 billion, we should have 2020, we're going to say. A child born today will, their first car might be a hydrogen car. That's what, 2020. Hydrogen in cars. Well, yeah, let's take a look at that. First of all, there's a claim that hydrogen is the most abundant substance in the universe. And this is true. However, what they're talking about is giant molecular clouds of hydrogen in space, just like a cloud on Earth, but just a big cloud of hydrogen floating out in space. And the reason that it's a big cloud of hydrogen just sitting there is because there's no oxygen. Anywhere that you have oxygen, that oxygen is just want to grab onto that hydrogen and not let go, which is our situation on Earth. Almost all our hydrogen is in the form of water. So yeah, we have hydrogen everywhere. You know, we got a river pushing hydrogen right past us, but it's all in water. Water, H2O, one oxygen, two hydrogens. Okay, so well, why don't we just break apart the water? Two hydrogens right there, right? Right? Plenty of hydrogen. Unfortunately, yeah. Oxygen does not want to let go of those hydrogens. The energy required to break up a water molecule is actually more than you're ever going to get out of the two hydrogen atoms. So what's going on here? Turns out hydrogen is only an energy carrier. It's not an energy source. Yeah, there are no vast stores of hydrogen on Earth that are just sitting there waiting for us. We have to synthesize hydrogen, and it takes a whole bunch of energy to do so. But the claim is, okay, well, yeah, it's an energy carrier, but it's a really good energy carrier. You know, you can flow it, you can store it, you can put it in a tank, pipeline, you can dissolve it in other substances. No, it's a great energy carrier. Not like those batteries. You know, batteries, they're heavy. They take all this time to charge and recharge. They're expensive. They wear out on you. You know, your car, 6-8 years down the road, you know, oh, I got to change out my whole battery pack. Thousands of dollars. No, you want hydrogen, right? Well, let's be a little more skeptical. Okay, so oxygen doesn't want to let go of those hydrogens readily. It takes a whole lot of energy. But carbon, not so much. Hydrocarbons are then your next source of hydrogen atoms. You can peel the hydrogens off of anything, natural gas, propane, oil, anything. A little bit easier than water, but still, energy carrier, not an energy source. So all these people say, okay, yeah, well, we're going to use natural gas or propane or other petroleums. We're going to use that for a while until we get it right. Yeah, and once we get it right, we'll use water. Yeah. Any data. Methane. Unfortunately, this is a gambit here because we're coming up on peak oil when the price of oil is not going to go down anymore, but it's going to just keep going up and up and up. Natural gas is only a decade or two behind. So yeah, gas is a little bit more secure, a little bit cheaper than oil, but not for long. It doesn't give us a lot of time to work on alternatives, trying to get us back to that water solution. In fact, the U.S. used to be pretty self-sufficient in natural gas. Between us, Canada, and Mexico, that used to supply all of our needs. Now we're at like 85% domestic production and falling. And that's only going to get worse.
What's the competition between methane? What's the relative merits of running a fuel cell off of methane versus running it off of hydrogen?
See, there's the trick. Okay, slide or two. So, let's say a miracle occurs. We get a whole bunch of hydrogen. Okay, well, we gotta store it and transport it somehow. How? 427F. Not going to work for cars. Not going to work for cars because even at 427F, even with the best insulation that humankind has, and we think we're coming up to the theoretical limits, a hydrogen tank in air will still slowly boil off hydrogen, even with the 99% insulation. That's about a week or two that your hydrogen tank is going to empty on you. All this time, it's hissing off a little bit of flammable hydrogen. Unacceptable. Yeah. And just aside from flammability, who here has a dipstick that checks their fuel tank? No. You put your fuel in your car, you drive. No one's going to accept a car that runs for 2 weeks. Like, oops, no, I didn't drive it. Oops. Okay, well, what if we keep it at room temperature, but we're going to use ultra-strong tanks. And with these ultra-strong tanks, we'll just be able to just cram it in there. Unfortunately, you're competing with gasoline. And gasoline tanks, there are still some vehicles out there whose gasoline tanks are made out of the same plastic as milk jugs, polyethylene. Obviously, it's a whole lot thicker than a milk jug, but yeah. Let's see. So today we have our gas tanks are made out of the same stuff as milk jugs. Or tomorrow, we want to sell you a car with gas tanks made out of aerospace-grade carbon fiber. Yeah, the fuel cell itself is already going to cost you a premium over a gasoline car. And then you got to make your fuel tank out of aerospace grade material, not milk jugs. That's 2 strikes. That's just in storage, not sourcing. Okay, well, how about metal hydrides? Yeah, I mentioned the hydrogen molecule is small, so you can actually diffuse it into crystals. And why don't we try that? We'll put it into the spaces between crystals. It'll sit there at room temperature, atmospheric pressure, and then we'll tap it whenever we need to start the engine. Unfortunately, it's a little more complicated than that. Trying to get the push and the pull and good flow rates out of crystals. Still a problem that we're working on. And in addition, it's a problem we're working on for batteries. All the hybrid cars that are out now, their batteries are based on nickel metal hydride technology. Oh, metal hydrides. So if mankind ever reaches the point where we perfect or where we get really good metal hydrides to store our hydrogen, we'll already have these great batteries. They'll charge and discharge really quick. They'll be well characterized. They'll last a long time. They'll have lots of power. So that's not an advantage for hydrogen. That's a disadvantage for hydrogen because it doesn't put you over your competitors. It keeps your competitors with you. It lets your competitors keep up.